This is the On Humans podcast with your host, Ilari Mäkelä. And today's episode is a mind-bending one. In some sense, it's one of the more technical ones that I've ever had the courage to do. But on the other hand, it's not. It's about questions that even young children ask. Is there a biggest number? Is there an edge to the universe? Does time have a beginning? And if God is not supposed to be a big man on the cloud, then what is God supposed to be? More generally, what is infinity? And can we even understand this idea? Will infinity forever escape the grasps of human understanding? Or have the recent developments in especially mathematics finally given us a firm grip on the infinite? And I have a very special guest to guide us on this journey through the long and strenuous efforts of philosophers, scientists, mathematicians, theologians to try to grapple with this idea that so fascinates and so eludes us. The guest is Professor Adrian Moore. Moore is a world expert on the matter, and he has a wonderful BBC series, which I can highly recommend. I will leave a link to it in the show notes. More personally, though, Adrian Moore is the head tutor of philosophy at St. Hugh's College, Oxford, which was my home for 3 years. I did my undergrad in philosophy and psychology at St. Hugh's. And it's very close to 10 years from the day that Professor Moore himself interviewed me, and for whatever reason, accepted me as a student. So this was a very special occasion for me, and it was just wonderful to talk with him. We talk about a variety of topics, from why infinity so fascinates us to a short history of philosophy of the infinite. We meet people like Aristotle, Zeno, we meet Achilles racing against the tortoise. But we also finish with some very recent fascinating work around infinity, especially the wonderfully weird character of Georg Cantor, a German mathematician who, before having a somewhat tragic ending in a lunatic asylum, had been able to prove that some infinities are bigger than others. A really mind-boggling concept, but one that I think that Professor Moore is actually able to explain in a way that even a non-expert can appreciate. And we finish with some thoughts on where does this leave us? Do we understand infinity today? What is the relationship between infinity and human understanding and the human condition itself? I hope that you enjoy this conversation. If you do, please do subscribe to the show if you haven't done so yet. And if you leave a nice review on Apple Podcasts or Spotify or whatever app you're using, that really means a lot to me. I also wanted to take a moment to thank all my Patreon supporters for the really incredible amount of extra motivation and genuine material support that you all give me. If you're considering to join these wonderful people, the way it works is that you can chip in a small amount, a sum, $6, even less, a month to show your support. You can do this at patreon.com/onhumans. Thank you so much for considering. So again, that's patreon.com/onhumans. Anyway, let's get back to the episode, to this very special episode with the person from whom I have learned probably the most about the art of gentle, non-antagonistic, and curious conversation, Adrian Moore. Professor Adrian Moore, welcome to On Humans.
Thank you very much. It's really kind of you to invite me.
I've had a fair bit of fun during the past couple of weeks telling my friends what the next topic in my interview list is. And whenever I say that it is infinity, I get quite a particular reaction. And I've covered a fair amount of different topics, some more esoteric than others, but no other topic, when crystallized into one word, has brought quite a particular reaction. Like, why do you think this is?
It's a topic that has captured the imagination ever since people have been thinking. I mean, you can go right back to ancient thought and see examples of people grappling with this topic. And it is a good question that you've raised. Why is this a topic that exercises people as much as it does? And I think this gives me an early excuse to emphasize something that I always like to emphasize when I'm talking about the concept of infinity, which is that there are two separate strands, really, in the history of thought about infinity. If you just say the word infinity to people, on the one hand, there's a good chance that they will start thinking in mathematical terms. And perhaps what will come to mind is the fact that the numbers, the counting numbers, 1, 2, 3, 4, 5, etc., go on endlessly. There's no biggest number. Or they might have in mind, if not mathematics itself, the application of mathematical ideas to space and time, for example, and the idea that, maybe time goes on forever, and maybe space goes on forever. And that would be another application of this sort of mathematical idea of the endless or the limitless or the boundless. These are all variations on the same theme. And so you've got that cluster of ideas. But the other thing that might happen if you just mention the word infinity to somebody is that rather than beginning to think straight away in mathematical terms, it may be that the first thing that comes to mind is the idea of God, the idea of an infinite being, a perfect being, an all-powerful, all-knowing, perfectly benevolent being. And those that have a religious faith or a belief in God will very often think of God in terms of this concept of infinity. And that's another strand in the history of thought about infinity. But I'm very conscious of the fact that I still haven't answered your question, actually, because all I've done so far is to distinguish these two strands in the history of thought about the concept. But I think there's a sense in which we can give the same answer to your question, whichever strand we're focusing on. And it has to do with the fact that we ourselves, human beings, are fundamentally finite. And we can say that whichever kind of infinity we're talking about. If you're thinking in basically mathematical terms, there is the sheer fact that we're tiny.
Yes.
If we take up a tiny amount of space and we live for a tiny amount of time. And it wouldn't matter if we took up a lot more space and lived for a lot longer. We would still only be finite in a very literal and very crude sense. We're mathematically finite.
And maybe that's from one of the reasons why the starry sky is such a kind of symbol of it. It's actually, I think it's the book cover of your book on the topic, right?
Yes, exactly.
And whether it is actually infinite is I guess up to cosmologists, but it is perhaps the starkest contrast we can think of to our
Yeah.
own size and time span.
Well, exactly. There is something awe-inspiring about the night sky, and it's a reminder that we are mathematically finite. But of course, we're finite in the other sense as well. Do you remember the other strand was the theological strand? And whatever exactly it is that we have in mind when we talk about God's infinity, certainly we're ascribing to God properties that we would never dream of ascribing to ourselves. We're not omniscient, we're not all powerful, we're not perfect, we're not completely self contained, etc., etc. So, in both senses of the infinite, we ourselves are finite. One of the basic features of our condition is our finite nature. So to go back to your original question, I think part of the reason that it fascinates us and intrigues us is that it's tied in with self-consciousness about our own nature. Um, Thinking about our own limitations puts us in mind of this contrast with what is unlimited. And as you yourself quite rightly pointed out, the night sky is a wonderful image of this. Whatever exactly is going on out there, whether it's finite or infinite, it gives us a sense of the infinite, and it gives us a powerful reminder of our own finite nature. And I think that's part of a significant part of the answer to your first question. Human beings have always been interested in the infinite because they've always been interested in themselves. ourselves.
and on the flip side, that which contrasts most to ourselves.
Exactly,
Yeah. Yeah.
exactly.
I do think it's a fascinating topic. I mean, there's a I've I don't know how tongue in cheek this was, but I do remember hearing you say that philosophy is the profession of never growing up.
Yes.
And keeping the kind of childlike wonder and asking questions, and infinity is something that little children, they ask these questions, well, what's the biggest number, and how big is the universe? And I have a vague memory of being fascinated by just the symbol of infinity when I was young.
I mean, you're quite right. I mean, I'm forever telling people when they ask me what a philosopher is, I'm forever saying a philosopher is basically somebody that's never grown up. And I think this is a really clear example of what I have in mind. Philosophers are exercised by the sorts of questions that already exercise little children. You don't have to be very old before you're already beginning to wonder what the biggest number is, or whether there's anything outside space. I mean, children will often ask that question, or they're told that God created the universe and they ask, well, who created God? And already I mean, they're not putting it in these terms, but already they're thinking about issues of infinity. Um, but it's a topic that has a very technical side to it as well, some really quite sophisticated mathematics that can be brought to bear on the infinite. And again, uh, I mean, I would say this, wouldn't I? Because I'm a professional philosopher. But again, this reminds me of philosophy. I mean, on the one hand, we're people that have never grown up. Um, and on the other hand, we do actually uh, develop quite technical, quite sophisticated, quite adult resources uh, to um, to bring to bear on our own childishness.
Yes.
Yeah. And it is, and it's another clear example of that.
Okay, well, with that, with this preface, let's let's get to the history and the philosophy of infinity. So, our long attempts, in this case, especially in the Western canon, to grapple with the idea, would it be right to summarize the kind of long arc of history into saying that there are three main acts? The first act is the Greeks, who tend to dislike, abhor infinity. Then there are the medieval Europeans and some early modern Europeans who take the opposite view and who see, I think probably due to the influence of Christianity, see something deeply positive in the infinite. And then there is the last, I don't know, 4 3 to 100 years, when infinity is still on the agenda, but it's the deeply technical question, and perhaps so technical it might have pushed some of the more generalist minds away from the topic. Is that a roughly accurate characterization of the kind of broad brush history of infinity?
I mean, if anything, that's too good a characterization because you're doing my work for me. I mean, I think that's a really good characterization. But of course, like any summary of that kind, there's going to be an element of oversimplification. But at this level of generality, I think your summary was excellent.
Well,
Yeah,
let's go to the dirty details. I think Aristotle is kind of the most, not only important thinker there, but I think is a very useful thinker for our purposes, because he seems to interact with a lot of the strands of Greek thought with infinity. And he was not happy with what he called actual infinity, right?
yeah.
But he allowed what is kind of not real infinity, which is this potential infinity. Could you either correct me or elaborate on that?
Well, let me say something about that. So Aristotle is a really interesting figure in connection with infinity, just as he is in connection with pretty much every other topic as well. But as far as infinity is concerned, he was in a way reacting to the very thing that we've just been talking about, which was this Greek tendency to be suspicious of the infinite and to think of it in derogatory
Hmm.
terms as something that if they possibly could avoid, they should. And if they, in particular, if they could avoid thinking about it, they should.
Yeah. I think as an instance of as evidence of that, the fact that this was a deeply patriarchal culture with most of the philosophers being men, it wasn't uncommon to equate the infinite with the female, right?
Yeah. Yeah, that's right. The Pythagoreans recognized what they referred to as a table of opposites, um, with the finite and the infinite at the head of these two tables, and included in the concepts that went with the finite were the good and the male, and included in the concepts that went with the infinite were the bad and the female. So there is a kind of sexism that's very firmly rooted in ancient Greek thought there.
I think it's interesting, not just from because of history of sexism, but also just because it's both a kind of piece of evidence about this dislike of the infinite. And I just think it's so strikingly different to what my kind of modern intuition is. I mean, if I say that they associate the female with the infinite, my first reaction would be like, well, it might be this kind of othering, but it's a positively mystical othering. I mean, there's a very strongly positive connotation, which they did not have, right?
That's right, and you've used the expression "the other end," and I think that really is significant because the people that were having these thoughts were men.
Hmm.
I mean, it's almost as simple as that. I mean, actually, this goes back to what I was talking about earlier. That in a way, what's going on when people are exercised by the infinite, even if they're troubled by the infinite, that there's self consciousness of their own finitude, and there's this um, sort of contrasting infinity that's out there, that's the other. Now, when I first made that point in this conversation, I had in mind by how we think of ourselves. I had in mind how we human beings think of ourselves, but to some extent, you have to be in different contexts. You have to be more specific than that, and to some extent, it wasn't a matter of how we men think about ourselves, and that comes into this Pythagorean table of opposites.
A very fascinating thing, yeah. But sorry, there was a small caveat. You were explaining that basically the background to Aristotle being this Greek dislike of the infinite, and he's trying to get some of it, but not the whole abhorrent whole.
Well, that's the thing. So this is the context in which Aristotle finds himself. This milieu where there's this suspicion and abhorrence of the infinite, but uh, for various reasons, Aristotle wants to say it's not as simple as that. There are ways in which we have to acknowledge the infinite. So Aristotle is interested in trying to have his cake and eat it. He wants to know how he can respect what these other great Greek thinkers had to say and accommodate their abhorrence of the infinite on the one hand, and on the other hand, do justice to the fact that in some sense we do have to acknowledge the infinite. And in some sense is the operative phrase, because what he does is he distinguishes two senses. And he says, look, we can distinguish between two ways in which the infinite might exist. There's this distinction between the actual infinite and the potential infinite, or between the infinite existing actually and the infinite existing potentially. And the idea was, it's quite a simple idea, actually. The idea was that something is actually infinite if the infinity is there all at once,
In one moment,
in one moment. That's right. That would be an actual
but it's only
infinity.
potential if given more time, there is no limit to it.
Exactly. So the potential infinite is the kind of infinity that's spread out over time.
So in a way, I think it would make sense with counting numbers, because there, I guess what he would say is that we can count 1, 2, 3, 4. If we never stop, we never stop. So there is a potential
Yeah.
infinite, but we've never actually counted them all. They are never actually here in front of
Yeah.
us.
Absolutely. I mean, that's right. And the crucial word in what you just said was the word never. We never get to the end. We never count them all. Now, never is the crucial word, because that's a forceful reminder that we're thinking in temporal terms. When we say that there are infinitely many numbers, this is a clear example of the potential infinite, because this is an infinite that is spread out endlessly. You can keep going forever and ever. If space were infinite, that would be bad news for Aristotle, because that would be a kind of infinity that was there all at once. And that's what he um, repudiated. That's what he did not believe in.
What did he say to those? Because this is where the childhood like curiosity comes in. Okay, I'm at the very end of the universe. I push out my hand. What happens to it? Well, it's not only children. It's also Aristotle's contemporary, I guess, Archytas,
Yeah.
had this thought experiment. And what was Aristotle's response to this? Like, if space is, if infinity is something that can only exist in this kind of potential, well, if you never stop, you never stop, way, but it's never here all at once. So then space is finite. What does happen to you when you're at the edge of space and you push your hand up?
Well, I mean, as far as Aristotle's own answer to this is concerned, I'm not sure, to be honest with you, that he has ultimately a really satisfactory answer to this. Nevertheless, it's really striking that, in fact, Aristotle ends up saying something that's very, very much like what a lot of contemporary physicists would say. I mean, it's not completely uncontroversial, but a lot of contemporary physicists do believe that space is finite but unbounded. That's the phrase that's often used. Now, we do find it very hard to understand, but here's an analogy that may help. Um, we, as it happens, we are three-dimensional beings. But suppose that we were only two-dimensional beings. Suppose that we were like shadows and we exist on the surface of a sphere, like the Earth, let's say. So we're two-dimensional beings crawling around on this surface. If you keep crawling, you're never going to get to the end of it. Um, but in fact, what would happen if you really kept crawling, and if you didn't encounter any obstacles like oceans or whatever, in fact, what would happen is that you'd eventually find yourself back where you started. Um, and again, there are physicists who tell you, well, it's a bit like that. It's a three-dimensional equivalent of that. We can talk about space in the way that Aristotle wanted to talk about space, as finite, but without edges.
But that's fascinating. By the way, I do want to ask one thing here, which is maybe a little bit of a caveat. Maybe we keep this in brackets, so to speak. But Aristotle doesn't isn't happy with this idea of anything being really infinite, except for for time. But there are people who might say that that's actually the least uh, intuitive thing. I remember reading, I think it was in your book, I read about a joke that Wittgenstein um, said, which was that you meet someone who says 4, 1, 3, phew, done. And you ask what they were doing, and they say, I just finished counting pi backwards. I have been doing it since infinity. And that strikes us as completely absurd. Now, I don't know what exactly Wittgenstein was trying to convey with this joke, but what struck with me was that this could be used as, I mean, and the whole discussion of infinity is just full of paradoxes, but this to me sounds like a deep paradox with the idea of time going infinitely far back.
Well, it is true that when you think about time as being infinite, it's definitely true that there's a really fundamental distinction between the past and the future in our intuitions. And a lot of people would claim that they are quite comfortable with the idea that time goes on indefinitely into the future, but find the idea that time is extends infinitely far back into the past much more problematical. Um, and the Wittgensteinian joke is sort of tapping that asymmetry. I mean, there's a huge controversy about this, but there's a whole school of thought that it really does not make sense for the um, past to be infinite, and that's a worry that a lot of people have had about Aristotle's position.
But I guess before we worry too much about it, it might be good to motivate him. I mean, he's trying to solve um, famous paradoxes with his view, paradoxes that emerge from taking infinity too seriously, maybe, perhaps he would say. The most famous probably being Zeno's paradoxes of motion. What would be your favorite example of Zeno's paradoxes and how Aristotle solves them?
This is interesting because it's a stark illustration of the fact that the ancient Greek thinkers were often suspicious of the infinite. And part of the reason, perhaps the main reason why, was that it did seem to be riddled with paradoxes. And Zeno, an ancient Greek thinker, is famous for having formulated a number of paradoxes. And the most famous paradoxes are all concerned with, as it were, the infinitely small rather than the infinitely big. And I think um, probably the most famous of these paradoxes is the paradox of Achilles and the tortoise.
Yes, I know that this is used in interview questions at Oxford. You did not use it when you interviewed me, but
Not when I interviewed you. On other occasions, I have. But it's a good question to bring up in the context of an Oxford interview because whether you're encountering it for the first time or not, it's very puzzling. It's very hard to know what to
yeah,
say.
yeah.
Um,
I did tease my flatmates with this before our interview, and this is
I mean, I would have been pleased to be a fly on the wall and to hear what sort of reactions you got.
one of them actually arrived at Aristotle's solution pretty
Ah,
much,
okay.
by himself, yeah.
Okay.
But anyway, before we get ahead of ourselves, so, Achilles and the tortoise.
Yes, we need to set the paradox up, I guess, don't we, before we can consider Aristotle's solution. So, for listeners who haven't come across this paradox before, it's a paradox about a foot race between Achilles, who runs very fast, and a tortoise, who is obviously much, much slower. And because Achilles is so much faster than the tortoise, it's clear who's going to win. It doesn't seem to be a particularly fair race unless they somehow do something to make it fairer. And so they do something to make it fairer, which is to say they give the tortoise a head start. So let's imagine, for the sake of argument, that Achilles runs 10 times as fast as the tortoise. And let's imagine that the head start, which the tortoise has, is 100 meters. Let's also imagine that the race as a whole is a kilometer for Achilles, 1,000 meters for Achilles, but only 900 for the tortoise because the tortoise has got a head start. So the tortoise has a head start, but even so, I mean, you can do the arithmetic, and it's clear that actually Achilles is still gonna win this race. I mean, he's so much faster than the tortoise that he will eventually overtake the tortoise and then race on and win the race.
However,
However, and this is the paradox, there seems to be a compelling argument to show that Achilles cannot overtake the tortoise. And the argument goes as follows. Um, somebody fires the starting gun and they both start running. And the very first thing that Achilles has got to do is get to the point at which the tortoise starts. And you may remember we gave the tortoise 100-meter start. So the first thing that Achilles has got to do is run that 100 meters.
yeah, yeah.
Now, the tortoise is a lot slower than Achilles, but nevertheless, the tortoise is making some progress. And during the time that Achilles runs 100 meters, the tortoise is able to advance 10 meters.
Yes, yes.
So Achilles gets to the tortoise's starting point, but there's still a gap between them. There's now a 10-meter gap between them. So now Achilles has got to make up that gap. And of course, he can do that. He can run 10 meters. But in the time that it takes him to do so, the tortoise advances 1 meter. So Achilles is getting closer, but there's still a gap. So now Achilles has got to make up this 1 meter gap. And so you can see what's happening here. The argument is that there's always going to be a gap. And that gap is getting smaller and smaller, but it's never disappearing. And this is the paradox, because it seems to follow that Achilles cannot overtake the tortoise. He can get closer and closer and closer, but always there's a gap, and it's a gap that's getting smaller and smaller, but it's never disappearing.
Because yeah, it's 10 centimeters, then it's 1 centimeter, then a tenth of that, etc. But I think the etc. is the operative expression there.
The etc. is the operative expression. That's exactly right.
Yeah.
Uh, Little gaps that are getting smaller and smaller and smaller, but this is going to go on forever. And that's why it's a paradox about infinity.
So, am I right, by the way? And this is just a very brief question before we return to the main point. What exactly was Zeno's conclusion? Do I remember right that he's basically just saying that movement is an illusion? Is
Yeah,
it
I mean, this is the really striking thing about Zeno himself.
like he bites the bullet?
Exactly, he bites the bullet. Most people treat this as a puzzle that needs to be solved.
Yeah.
Zeno used this paradox and a number of other paradoxes to argue that the very idea of motion is incoherent, and we look around the world and think that we see motion and think that we see change of other kinds, but Zeno's own conclusion is that this is just an illusion, and we have to dismiss it as an illusion because we can't ultimately make sense of it.
Well, assuming that we don't go down that path, and we do regard this as a puzzle that needs to be solved, um, maybe we can play a tutorial, and I can give my take on how Aristotle solves it, and then you can give me a grade.
Okay.
So Aristotle makes a distinction between the actual infinite and the potential infinite. And he really only believes in the potential infinite. As an example, if I count 1, 2, 3, 4, I might go on and forever. Um, but it's only potentially infinite. I never have all the counting numbers here at once. But in the same way, now let me try to think this. So, in the same way, what Aristotle would say is that yes, if every time Achilles gets to the tortoise and the tortoise has moved a little bit up, there would be an actual pause. And then again, every time the Achilles has gone now 10 meters, the tortoise 1 meter, we would pause. Then Achilles 1 meter, tortoise 10 centimeter, then pause. If we were to actually pause infinitely many times, if we would never stop that pausing, Zeno is right. Achilles would never overtake the tortoise. But in a normal setting, in a normal race, you wouldn't do that. So there is a potentiality that we could divide this infinitely many times. But as long as we don't do it and pause every time, there's nothing to be worried about.
Good. Yeah. Yeah. I mean, it's actually a little bit easier, I think. Uh,
Okay.
uh,
So I did not get a first class there.
no, 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 you did get a first class. No, what? No, I was going to say, it's actually a bit easier to think about Aristotle's solution in connection with another paradox. Um, I mean, they're all variations on the same theme, actually. But there's another paradox where you just get rid of the tortoise and you just have Achilles on his own, and he just wants to run from A to B. He's not racing against anybody. He just wants to get from A to B. And we could divide it up into tenths if we wanted to, but let's divide it into halves. The paradox is, look, Achilles can't get from A to B because that would involve doing infinitely many things in a finite amount of time. First of all, he's got to get halfway, 500 meters. Then he's got to get 3/4 of the way, 750, etc., etc. And once again,
Again, the etc. is the devil.
exactly. Once again, this is the operative phrase. That's right. And the worry is that Achilles has got to do infinitely many things to get from A to B. And Aristotle says, well, actually, no, you only do something, according to Aristotle, if you actually do something. So if Achilles runs from A to B, it is true that he passes the halfway mark. Um, but that doesn't involve him doing anything unless he actually literally stops
Stops or raises his hand or
or
something.
raises his hand
Yeah.
or throws a flag onto the ground for somebody to plant it there or whatever. But the sheer passage through a point doesn't constitute doing anything for Aristotle. So he's going to say there's a potential infinity here, in as much as if we wanted to, we could start dividing the route up. We could plant flags at relevant points.
And indeed, if Achilles were to plant infinitely many flags, Achilles would never get to the goal. Yeah.
Well, that's right. I mean, he can plant as many as he likes in theory. I mean, in practice, it may be that he can only plant two or three. In theory, he can plant as many as he likes as long as it's finite. What he can't do is give us an actual infinite, and this was the distinction that Aristotle drew.
Yeah, and this became really the kind of standard theory of infinity in Western philosophy for almost 2 millennia or something, right?
Yeah, yeah, no, that's right. I
Okay.
mean, Aristotle's thought about infinity dominated, um, and it, for as you say, for over 2,000 years.
Yes, yes, yes. I do have a quick question, and please, you can actually really answer this very quickly if it's a clear case about Aristotle's influence. And the question is, um, I understand the potential actual distinction making a lot of sense for the Greeks. The Greeks, they say this whole infinity business is very troubling. We don't like it. But then Aristotle comes and says, yeah, but you kind of have to have, for example, the numbers, they are infinite. So in some sense, so you have to have a compromise. Okay, here's a compromise. I'm a little bit surprised that this was then still the norm in the medieval times, because in the kind of really rough sketch of the history of infinity, of thinking about infinity, the medieval times were the times where the abhorrence of infinity turned into reverence for infinity. And I could in particular imagine um, medieval thinkers, Christian thinkers, saying something like the God is actually infinite.
Yeah, good.
And
Eh,
so
yeah.
what's the relationship between that kind of thinking and then the continuing impact of Aristotle?
Yeah. Well, I think I can answer that question. You may remember we distinguished between a kind of metaphysical or theological understanding of the infinite and a more mathematical understanding of the infinite. Now, the Greeks were troubled by all of it. By the time of the medievals, as you quite rightly point out, there had been a significant shift, and by then the idea of the infinite was something that was an object of admiration and awe and respect, and it had positive connotations rather than negative connotations, as long as it was understood in these metaphysical terms.
Aha. Uh-huh.
So, when God was said to be infinite, that meant that God was perfect and self-sufficient and
But not infinitely big.
not mathematic. No, because I mean, apart from anything else, I mean, God is not infinitely big because God is outside space and time.
Yes, yes, yes. One, yeah, that makes sense. Yeah, yeah. Well, that's a clear answer. Yeah.
Yeah, and when they were thinking about the infinite in a mathematical way, they were still troubled by paradoxes.
Yeah, but I think now the big question is, why do we say Aristotle was the the authority on this? Um, if you just open a Zeno's paradox Wikipedia page or something, typically the solutions nowadays that are suggested are not the Aristotelian solutions. We mentioned one small problem with Aristotle, which is the difficulty in understanding even infinite time. Okay, that's a problem, but my impression is that that's not the problem.
Mm.
Why Aristotle fell out of favor. So, what is the problem or the reason, or however we want to frame it, why Aristotle fell out of favor somewhere, and when did this happen?
Well, certainly as far as Zeno's paradoxes are concerned, mathematicians did begin to think about them in non-Aristotelian terms, and I guess the really significant breakthrough as far as that goes was the invention of the calculus in the 17th century.
Yeah, so this would be Newton and Leibniz.
Yeah. And one thing that's worth noting, even before you get onto the calculus, is that if Achilles does get from A to B, and if we do think of the space that he traverses as divided up into infinitely many segments, let's not forget that the time it takes him is divided up into infinitely many segments as well. So,
Okay, yeah.
he's got, I mean,
Interesting.
insofar as the space involves infinity, well, the time involves infinity as well.
Okay, so he kind of has an infinite amount of time to do infinitely many things.
Yeah, I mean, you can almost look at it that way. I mean, that's a rather crude point, and it doesn't require the calculus to notice that point. But it does constitute a significant point, I think, in answer to Zeno.
Well, then back to why Aristotle fell out of favor. One is that we start having new mathematics and new kind of responses to Zeno. But Aristotle is not just talking about Zeno, he's more generally trying to tame infinity and almost explain away any idea that there would be any real infinity here
Yeah.
now. Does that get challenged?
Yeah. Yeah, and we have to come forward actually to even more recent mathematics. The crucial mathematics, as far as this goes, was as recently as the 19th century. And in the 19th century, there was a significant breakthrough with the work of a German mathematician, Georg Cantor. He was a brilliant mathematician, and he did something that had never really been done before. I mean, there were precursors of a sort, but for the first real time in the history of mathematics, Cantor supplied a very rigorous, precise account of how we should understand the infinite, and showed that we can do mathematics with the infinite. I mean, up until then, there had tended to be an assumption that the only mathematics that we could do was mathematics with finite quantities.
There's actually a funny story I have about this. I have a good friend who was also he was an undergrad during at the same time at St. Hugh's, and he's a mathematician.
Mm.
He would qualify that by saying he's a pure mathematician,
Right.
and he works he works with transfinite mathematics,
Mm.
and his master's thesis at Oxford was concerned checkers, not chess, but checkers, if I remember right.
Yeah.
But for those who are not, I don't know if how popular checkers is nowadays. But anyway, the board looks like a chessboard. Um, but he worked with checkers on an infinite board,
Oh, oh,
and he was very firm when explaining this. It's not a very big board.
yeah.
it's an infinite board.
Right.
And he proved theorems on how the game would proceed
Mm.
if you have two rational agents playing on an infinite board, which of course went over the head of anyone who was kind enough to listen to his explanations. But I did, when preparing for this discussion, actually want to press him a little bit on it. And my inner Aristotelian came through, because I said to him, look, I think I understand. It's actually not so complicated after all. Because in a way, it's very arbitrary that we say that it must be 8 times 8 or 10 times 10 or 11 times 11, whatever board you want to pick, whether big or small. It's a bit of an arbitrary limit. So when you play with an infinite board, you just don't have that arbitrary limit. You can kind of go on forever, right? And he said, no, 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 no. That's not a potential infinite. No, that's not what I'm doing. I have an actually infinite
Right.
board
Right.
where you have, and the most important, the crucial point was that there are infinitely many pieces on it
Mm.
at every move.
Yeah.
And so there are moves, for example, where you jump over an infinite amount of opponents' checker pieces, and then of course I again had to say, okay, then I just don't understand what you're doing.
Yeah.
But I think that it was a very visual way to see this transition from an infinity can only exist in a potential way to, there is a mind-boggling form of mathematics where it's here all at once,
Yeah.
right?
Yeah. 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 Well, that's a really nice illustration of why this seemed to be such a significant anti-Aristotelian moment in the history of mathematics, because, here at last it seemed as if this mathematician Cantor had given us the wherewithal to talk about the actual infinite. And of course, that was exactly what Aristotle did not want.
Yeah, yeah.
My own view is that in a funny kind of way, Cantor's work ends up being a vindication of Aristotle rather than a refutation of Aristotle.
Okay. I'm very curious. I wonder if why don't we do a quick introduction to listeners and kind of check for me if I've understood, at least on a superficial level. So, not only does Cantor find a way to do this kind of the infinity is actually here at once kind of mathematics, but he does something which is ultra weird,
Mm.
which is that, I mean, infinity is full of these paradoxes. One of them being that, I think, was it Galileo who noticed, or who noted that there is this weird thing in which, of course, if we take all the counting numbers 1, 2, 3, 4, 5, etc., and then we take all the, say, odd numbers 1, 3, 5, etc., we would want to say that the first group is bigger than the second group, but actually they're both infinite, so they're the same size.
Mhm. Yeah. Yeah.
And this is a bit of a mind-boggling thing. That, okay, so we have this group which obviously is bigger, 1, 2, 3, 4, 5, 6, 7, 8, whatever. Then we have a group that is should be half of the size, but hey, they're both infinite, so they're both the same size, and there's a more rigorous way to say that same thing. But what Cantor does is say that yes, those two seemingly different sized groups are infinite. They are the same size, but there are groups that are also infinite and are bigger. So there are different sizes of infinity, right?
Yeah. Yeah.
Which is ultra weird.
Absolutely. That's right. I mean, the first thing that you notice when you're doing this work is that some infinite collections are the same size, where you might have been inclined to say that one was bigger than the other.
Yeah.
Galileo is often associated with this paradox. I mean, other people had noticed it as well. It wasn't Galileo who first drew this to our attention, but he did talk about it. Actually, his own favorite example involved square numbers.
Yeah, yeah, yeah. Is there any easy way to explain why?
Yes, let me say why Cantor wanted to argue that these were the same size. One way to think of this is as follows. Sometimes I'm in a position to know that two collections are the same size, even though I don't know exactly how big either of them is. So a very simple example of this would be, I know for a fact that the number of firstborn twins is the same as the number of secondborn twins.
Yes, okay, I see.
Those are two collections that are the same size, the collection of firstborn twins and the collection of secondborn twins. But I can't tell you how many there are. I don't know the exact size. I just know that they're the same size. Now, why am I so confident that they're the same size? Well, because you can pair them off with each other. To each firstborn, there corresponds a secondborn, and to each secondborn, there corresponds a firstborn. I mean, another case would be if you were at an event like a football game, for example, with a very large crowd, and you look around, and you've got a rough idea how many people are there, but you don't know exactly how many people. Nevertheless, assuming that you've got some guarantee that there's nobody there that's disabled, you can be confident that the number of left legs is exactly the same as the number of right legs. Um,
Yes, because they just match, they map onto each other. Yeah, yeah.
they match up with each other. That's right. I mean, as I say, you would need a guarantee that there was not somebody missing a leg. No,
Yeah, with mathematics, we don't have to worry about that.
with maths, we don't have to worry about that sort of thing. So Cantor said, well, we're in that position. To every positive integer, there corresponds an odd one, and to every odd integer, there corresponds a positive integer. They can be matched up with each other.
And I guess you mentioned that Galileo was thinking about squares, and I think there it makes even that there it becomes super
Yeah,
intuitive. So you map 1 with 1,
yeah,
2 with 4, 3 with 9, etc.,
yeah,
etc.
yeah,
But I see, yeah, and so we are in this football stadium or firstborn, secondborn twin situation.
yeah,
Hence, the groups are the same size.
yeah,
Okay,
yeah,
and then we have to ask, well, how on earth can then there be a group which is bigger
yeah,
than an infinite
yeah.
group of this size?
Yeah, and the crucial thing for these purposes is that Cantor was able to prove rigorously that there are cases where you've got two infinite collections and you can't pair them off with each other in this way. Any attempt to do so is going to miss something out.
I actually asked this about this kind of Cantor's hierarchy. I asked from my mathematician friend whether you have different sizes of infinite checkers board, and he said, unfortunately, no. We only operate on the smallest infinite.
Yeah, yeah, yeah. The kind of infinity that he was talking about with the checkers board would be a paradigm example of the smallest kind of infinity.
Yes,
Uh,
yes.
I mean, that's bad enough.
Yeah,
Yeah.
but you did then. I think I agree. I worked with Cantor's proof once. It was actually in a philosophy and computer science seminar by
Uh-huh.
Peter Millikan,
Uh-huh. Yeah.
because there's a funny historical anecdote here that Gödel, right, uses the method that Cantor develops to prove his famous Gödel theorem, and that then influences Alan Turing,
Yeah.
who creates the Turing machine. So there is the almost direct link from this completely abstract mathematical, uh, almost like a game, some would say, all the way to the ideas behind modern computers and the cracking of the Enigma code, which is a very funny historical anecdote. But I agree, it's a very complicated proof. I did not understand it well, even after working with it for a while. So let's not try to bully the listeners to
Mhm.
understand it without even visuals. Um, but assuming that this is the case, assuming that we understand the basic idea, which is that the mathematical details aside, there is a proof that although many seemingly different groups of infinite things are the same size, but there are bigger infinities.
Yeah. Yeah.
Assuming that there is this proof. Now, this, as we talked earlier, seems very non-Aristotelian, but you said that you buck the trend here. Now I'm very, very, very interested.
Yeah.
Um, yeah, please, what's the hot take on Cantor's?
Okay, well,
Um,
let me see if I can explain this. And by the way, I should emphasize that this is a relatively unorthodox view. I mean, what I'm about to say is, I mean, this is my own take on these
all the
issues.
better, yeah.
I mean, I don't want to suggest that I'm the only person in the world that thinks this, but a lot of people would disagree with me. But anyway, let me try to give some indication of what I have in mind. So yeah, so first of all, there's the surprise that different infinite collections are the same size. Um, then you sort of get used to that and you think, well, maybe that's not so counterintuitive. Maybe that's just another way of saying they're all infinite.
Yeah.
Um, and then comes the next surprise, which is that there are different infinite sizes. Um, and what Cantor showed, one of the things that Cantor showed is that there are not just different infinite sizes, there are infinitely many different infinite sizes. Um,
Okay.
so
Okay.
collections can get bigger and bigger and bigger without end. So we've got all these different infinite sizes, and there's even such a thing as transfinite arithmetic. You can assign numbers to these different infinite sizes, and you can add them, and you can multiply them, and it's a whole branch of mathematics in its own right. Um, but um, one thing that Cantor was forced to say is that there are some collections that are so big that you can't even assign sizes to them. They sort of they take us beyond all of this transfinite arithmetic.
What
Um,
did he call them?
Various different things, but the terminology that perhaps is most relevant here is that he referred to them as absolutely infinite.
Okay.
And sometimes there was talk of inconsistent totalities as well, but the absolutely infinite.
Okay.
Now, so let's just park that for the time being. I mean, that's going to be relevant, but let's park that. Let's go back to our very first intuitions about the infinite. If somebody asks you, what do you mean by the infinite, or how would you define the infinite? I think there's a good chance that you would start using words like endless or unlimited or immeasurable. Now, what is Cantor doing? Cantor is showing that there are all sorts of different infinite sizes. Um, and that collections that we take to be infinite can actually be measured. You can say how many positive integers there are. There is an answer to the question, how many positive integers are there in Cantor's view? Um,
The small infinity.
yes. Now, what does that mean? Well, that means that the collection of positive integers is measurable. We can say how big it is. We can
Hmm.
specify clearly how many members it has. Um, what were we just saying? We were just saying that our idea of infinity involved immeasurability.
Hmm.
So, what's going on here? Well, arguably, what's going on here is that Cantor is showing that the set of positive integers isn't truly infinite.
Is in Aristotle's vocabulary, it's only potentially infinite and not actually infinite, or is it too early to import Aristotle here?
It's a little bit too early to bring in Aristotle, actually,
Okay.
because in a way it's even worse than that. I
Okay.
mean, most people think that
Well,
it's
now I'm interested.
right. So most people think that the collection of positive integers is infinite. What I'm saying is not that Cantor has shown that it's really only potentially infinite. I'm saying something more radical than that. I'm saying that Cantor has shown that it's finite
Okay.
because it's limited. It's limited in size. It's measurable. We can say exactly how many members it's got. There are other collections that have more members, which is why it's limited in size. And those other collections that get bigger and bigger without end. Um, so you've got the set of positive integers, you've got another set that is bigger, you've got a third set that is even
Mm.
bigger, you've got a fourth set that is even bigger, etc. So that phrase etc. kicks in again. Um, and the thought is that the truly infinite, that's to say the stuff that's really endless, the stuff that's really immeasurable, is what Cantor was calling the absolute infinite, which was that stuff that's so big that it escapes the mathematics.
Huh.
And this is why I think it, in a funny kind of way, it's a vindication of Aristotle, because what's going on here is that we're actually once again coming round to the view that the truly infinite cannot be subjected to mathematical scrutiny.
Interesting.
Yeah.
Um, okay,
That's
well, now we have this on the record. So the
yeah,
if somebody says that a classic example of infinity is counting numbers, the integers, whatever, we can say, well, hold on a second.
yeah,
It might not actually be infinite.
yeah. Um,
um,
I mean, of course, obviously, that's an unorthodox way of talking. Obviously, that's not something that any mathematician would be inclined to say, and obviously, that's not something that the non-mathematical guy in the street would want to say. So, I'm well aware that this involves a non-orthodox way of speaking. But my point is this. Um, Whether we like it or not, Cantor has shown that we've got to revise our intuitions and we've got to think about what we mean. I mean, if you go back to square one and say, well, look, what do you mean by the infinite? What we're inclined to say, what we would have been inclined to say before we'd encountered Cantor's work is we mean the endless, the unlimited, the immeasurable. And the endless and the unlimited and the immeasurable, those are not adjectives that apply to the set of natural numbers, the set of positive integers.
yes, not anymore.
Mm.
Interesting. Okay, well, actually, this might be a good moment to loop back into the very beginning where you made the distinction between um, the kind of mathematical and the theological understanding of the infinite. Cantor was deeply religious.
Yeah,
And I mean, my kind of vague understanding now is that he would have said something like, we cannot understand the absolute infinite.
yeah,
I have tried my best. I have shown the limits of human understanding
yeah,
of infinity and have shown that it has its limits.
yeah,
And it is in the absolute infinite that we would start to understand God, perhaps, or something like that. But we can never get there.
definitely. I mean, that's exactly right. So he
Okay.
was a brilliant mathematician. He was also somebody with deep religious conviction. The mathematics itself revealed this a radical kind of infinity, the absolute infinity that was beyond mathematical investigation. And Cantor's own belief was that this was giving us a sense of what God is like. That it was almost as if the mathematics was pointing towards this more metaphysical or theological conception of the infinite. And he actually believed that his mathematical abilities were a God-given gift. Um, that he believed that he had been endowed with this superb mathematical craftsmanship um, as a way of justifying certain orthodox beliefs about God and God's infinitude.
So does this go back to the perhaps something in the idea that one of the reasons why we are so exercised, why we're so fascinated by infinity is because it so contrasts
Mm.
to ourselves. And
Yeah,
now we perhaps understand after really having tried
yeah.
that it truly also contrasts to anything that we can understand.
Yeah. Yeah, that's right. I mean, Cantor's work in a way is a graphic illustration of this. And especially if my unorthodox take on it is correct, because in a way, what's going on there, certainly as I just presented it, is the moment that we can understand something, the moment we can get a grip on it and do mathematics with it, um, we sort of render it finite. The sheer fact that we've got it under control means that it's not infinite any longer.
Yeah. Yeah. You can never tame a wild horse so that the horse is still a wild horse.
Yeah, exactly, exactly. That's right.
I um I think so far where we have somebody might say that so far we've been looking at infinity in the wrong places though.
Mm,
Because there is the idea that we are this finite thing, I don't know, 170, 190 centimeters tall, whatever, and uh, and we are trying to find infinity in all of these things that seem to escape us. They
mm,
seem to be something very different, huge, like the starry sky. Okay, seems to be not necessarily infinite. The physicists say, okay, well, let's look at something like the numbers. They go on forever, unlike us. Okay, and trying to find these places which so contrast us that that might be where infinity truly is lurking. But there is another tradition, perhaps a bit more mystical tradition, but um, there's so many there's so many good quotations I could use here. I'm wondering which one to pick. I remember Wittgenstein said that perhaps there is a way that the eternal life does not belong to those who live forever, but those who live in the present. And there is that famous quote from William Blake about holding infinity. I think it's holding the infinity on the palm of your hand and eternity in an hour. And you actually start your book with a quotation from Kant. It's the very famous quotation that many people have heard about. The two things that inspire awe in him: the starry sky above him, and the moral law within. But you actually have the long quotation, and in the long quotation, Kant does not say that it's a starry sky that makes him think of true infinity. It is looking inside himself, and so there is this whole mystical tradition of finding infinity, not in a very long time, but rather in timelessness, in living in the present, or finding um, maybe finding infinity not by in something that's incredibly big in space and time or incredibly small in space and time,
mm.
but rather something that escapes space and time is how Kant saw this.
Yeah.
Um, what do you think of that approach?
Well, I'm sure that you're right to bring the discussion round to this because, as you say, a lot of people will think that this is what we really should have been talking about all along, and it's a very important tradition.
Are you attracted to that kind of thinking?
Yeah, I definitely see the attractions. What's really interesting about what you were just saying is that when people do think in terms of a more metaphysical idea of infinity, um, very, very often they're still not thinking about us. They're thinking about God. Um, and they still see a contrast with our own finitude. Whereas, interestingly, you were giving various examples of thinkers who wanted to say that in some sense, we ourselves um, could partake in infinity or have some sort of encounter with infinity. And it is a really powerful idea. I am attracted to it. I'm not so attracted to it that I would subscribe to it, because I do think ultimately that it does not make sense, unfortunately. But I say that in a non-confrontational way.
Yeah.
I say that
Yeah.
with a tone of respect. I mean, eventually, what I myself would want to do in response to these trains of thought would be to um, try to show how you can sort of have your cake and eat it,
Okay.
in as much as I do think that these ideas are ultimately incoherent, but I don't think that they're silly or useless, or ideas that should be dismissed. Um, what I do think is I think we need a careful account of how you can make use of what is incoherent.
Hmm.
Um, so that's having your cake and eating it. And that's
Okay.
yeah.
What would that look like?
So, I mean, what I just said was a little cryptic and a little tantalizing. I
Yes, yes. Tantalizing is a good word.
yeah.
I'm very tantalized. So.
On the one hand, we're talking about something that's incoherent, and on the other hand, we should be able to make play with it. But um, I mean, you mentioned Wittgenstein a little earlier, and actually, this is an idea that, in a way, comes straight out of Wittgenstein, and it's the idea that there are certain insights that we may be able to achieve as human beings that we can't really properly express for one reason or another. Um, and nevertheless, it may be interesting to see what happens if we try to express them. And my view is that um, sometimes what happens is that we come out with precisely this kind of incoherence. Talk about infinity, and especially this sort of talk about infinity, is the kind of thing that we resort to when trying to express certain insights that we have. But if I was spelling out this view in detail, what I would try to do is argue that it's not a proper expression of those insights. It's an unsuccessful attempt to express something that can't be expressed. So that's why you're having your cake and eating it, because you're acknowledging that the talk is incoherent. Um, but at the same time, you're also acknowledging the use that it has and the work that it can be put to.
And so we're gesturing towards the borders of our understanding and we can never go beyond them, but at least we're gesturing or something like that.
Yeah, yeah, something like that. Yeah, yeah, yeah.
Okay, wonderful. Well, a final question before we finish. How was all the research and teaching that you've done around infinity or philosophy more generally? How has it shaped your outlook on humanity?
Gosh, that's probably the hardest question of all. um, I do wonder whether um, it perhaps goes the other way round, in as much as certain views that I have about humanity and have developed over the years have shaped what I want to say about the infinite. Because I suppose that for various reasons, I mean, it's related to what we were just talking about. For various reasons, I can't shrug off the conviction that human beings are fundamentally finite. Um, we're limited. Those limitations are crucial. Those limitations are part of our very humanity. Um, and that in a way has constrained everything that I want to say ultimately about the infinite. And in particular, it's because of those convictions about our own finite nature that I'm inclined to say the kinds of things that I was just saying that talk about the infinite. The proper infinite doesn't ultimately make sense, because if it did, it would be finite. I mean, this is, this is the point which we saw in connection with Cantor. The minute that we can get our heads around it, the minute that we can make perfectly good sense of something, it's already finite.
So in a way, we believe that we cannot escape our finitude even in the realms of our understanding.
I think that is right. I mean, that's autobiographically right. I mean, whether that's philosophically right, I don't know. But your question was a question about how various views of mine have shaped one
Yeah.
another, and I think that's really what's going on here. Yeah.
Well, maybe I will also then end on a very short autobiographical note, which is that this was a big pleasure, but nothing compared to the pleasure of being 3 years under your guidance at St. Hugh's College in Oxford. So, Professor Adrian Moore, thank you so much for everything.
Well, thank you. It was a pleasure to do this recording with you. I have to say that was great fun. And if I may say so, it was also a pleasure to have you as a student at St. Hugh's College.
Okay, wonderful. Well, that's it then.
Excellent.
So that was it for today. Yeah, I want to congratulate you on getting through the more technical parts, especially one with Cantor's proof. You did well. You're still with us. And I want to say that if you like this kind of thinking, I think you would really appreciate episodes 30 and 31 with Donald Hoffman, where we even mention Cantor. But more generally, it's one of those mind-boggling episodes that pushes us to the very limits of our understanding of reality. I hope that you enjoyed that. I hope that you enjoyed this, and I hope that you enjoyed the show more generally. If you do, please consider showing some support. Share with a friend, leave a review on the app you're using, and consider showing serious support at patreon.com/onhumans. But whatever else you decide to do, I hope that you are doing well and that you will tune in next time. Until then, take care.